Hello guys, welcome to GetAlight channel. Today we are going to discuss about lossless and lossy joins and why these joins are required, why we need to decompose the table into multiple tables. This we are going to explain and you're going to understand this concept in further coming lectures in my normalizations. When you are doing BCNF, 3NF, 4NF normalizations, this join concept will be useful. If we want to store a big table in a database, it will take a huge space. Rather than storing a big table, we are going to split the table into many parts. And even if we join those table, if we are getting the same table, that will save the space now anyhow. So the company thinks and the organization thinks in like that way. So understand this: if R is a relation schema and is divided into sub-relation R1, R2, R3, R4 and so on, Rn. If R1 natural join, don't worry about this symbol, I will explain later. R1 natural join, R2 natural join, R3 so on natural join Rn is equal to R. Then it is lossless joint decomposition, or else it will be lossy joint decomposition. Now note it down. We are going to explain this, what is natural join, why join is required in next. Note it down first. Now for understanding lossless and lossy join, I am going to explain you natural join. What is a natural join? When you understand this, then you can understand that very easy. Now natural join, it is represented with this symbol RS. This is natural join, that means. So how to do natural join? First do the cross product. I will explain you what is the cross product. Cross product. Now check equality condition on common attributes and select them. We should check the equality condition which is there on the common attributes of the cross product, and after that project distinct attributes onto the table. Now you note it down. We're going to take an example and I'm going to do what is a cross product, then you can understand. We are going to go step by step. You may have some doubts, it will be cleared in later lectures. Okay, note it down first. Now look here, I am doing cross product of this table. This is PQR are the attributes of this table, 10, 50, these are the values, and I have decomposed this relation into two relations, R1 and R2 respectively. R1 has PQ attributes, R2 has QR attributes. Now I am performing R1 cross product R2. While performing cross product, just observe very carefully. This is R1 table I am writing it here. This is the R1 table, 10, 50 and 20, 50 and then 30, 80 are the values now. And this is the R2 table. R2 has 50, 50, 50, 80. And 80, 80. Now, what is mean by cross product? In cross product, this row should be joined with these three rows, that means. Similar way, this row should be joined with these three rows. Like that, the same for this row also. Now, note it down. I'm going to do this one, how the cross product will be working. Now, look at here. This is the R1 relation, this is the R2 relation. I am doing cross product. This is P attribute of R1, this means. This is Q attribute of R2, this is Q attribute of R1. These two Qs are different. This Q is attribute of R1, this Q is attribute of R2. I am writing it like this. This R2 dot Q means this Q belongs to R2, like that. So I am doing cross product here. First, this 10.1050, this row should be joined with these 3 rows, like that. So what is that row? 10, 50, then 50, 50. The first row of the next R2. And this 10, 50 should be joined with 50, 80. And this 10, 50 should be joined with 10, 80, 80. This 20, 50, the next row of the R1 should be joined with these 3 rows, like that. This 20, 50 with 50, 50. This 20, 50 with 50, 80. Like that you do. I am writing it here. So this is our table. You see, how many rows we got it? We will get 3 into 3 rows. That will be 9 rows. You see 1, 2, 3, 4, 5, 6, 7, 8, 9 rows. This is the cross product of R1 and R2. We can say the cross product has, this has 3 rows now, this has 3 rows now. So the 3 rows into 3 rows will be the number of rows in the cross product. You see, the number of rows in cross product will be C1 R1 into R2, where R1 is the number of rows in R1 and R2 is the number of rows in R2, like that. And number of columns will be C1 plus C2, where C1 is the number of columns of R1, C2 is the number of columns of R2, like that. This is very important concept. When you note it down, I am writing it like this. This is the number of rows in R1 cross R2. Now this is the number of columns. C1 plus C2 is the number of columns in R1 cross R2. You remember these are very important. Columns will be added, rows will be multiplied in cross product. Now I am going to explain you how to extract natural join from cross product. Now you note it down. Now up till now step 1 is completed. This is step 1. Now step 2. Which are the common attributes? We need to check what is the common attributes. Q is the common attribute between both R1 and R2 now. So take a look at this Q attribute. And now we should check the equality condition between the common attributes. So 50-50, these are equal. And now 50-50, these are also equal. 58, this is not equal. So this should not be included. That's all. 50-50, this is equal. This should be included. And 50-50, this also should be included. 50-80, this should not be included. 80-50, this should not be included because these two are different. We should check equality condition. 80-50, this should not be included. 80-80, this should be included. And I am considering this row too. Now how many rows we got? 1, 2, 3, 4, 5. Now you have understood the step 2 now. Now I am drawing the step 3 diagram. That is very important. Now this is step 3. In step 3 we should include only these rows which having the round. So I am including, this is the PQR, this is the final result, this is step 3. This is the P is 20. Both Q's are 50. So write 50 here. This should be included. And 50, write it here. And 10, 50, 50, 80. This row should be included with 50 here, 80 here. 20, 50, 50. Like that. And 20, 50, 80. And 30, 80, 80 like that. Remaining rows which are not equal should not be included here. Now this is the output of natural join. This is R1 natural join R2. That was R1 cross product R2. This was R1 cross product R2. That is R1 natural join R2. And this is what we required here. This is the final output. And you note it down. In next video, we're going to dive deeper into the lossless and lossy decompositions and understand how to solve problems on those concepts, because that is very important concept.